Hello, it's Keith here and this is lesson 5 of the platform-specific series of my ARM assembly programming tutorials. Today we're going to be looking at key and joystick reading on the Gameboy Advance, Nintendo DS and Risc OS. All of these systems have sort of different parameters. We're going to be reading in the keyboard on the Risc OS, the keypad on the Game Boy Advance, and the Keypad and Pen on the Nintendo DS. So we're going to go through all three of these. Now, depending on which system you're interested in, you may want to skip ahead. If you look below in the description, I'll have time codes for the various sections, so you don't need to see more than you want to. Anyway, let's go over to today's example and let's see it in action. So this is the code we're going to be running today, joypad.asm. So if we run this on Risc OS, we're going to look at Risc OS first. So here we go. Now we're reading in key presses and we're showing ASCII to the screen. So if I press space here, you can see hexadecimal 20, enter 0D, A is at 61, B is 62 and C is 63. So we're able to read in keys here, but this is going to be a bit problematic if we want to read in two keys at once, because if I press A and B, well, we just see 61, which is key A, so that doesn't help us. We're reading in a different way, up, down, left and right. If I press up, down, left and right, you can see we can read those in, and we can actually read in multiple directions at the same time. We can even read in all four at the same time, should we want to. I don't know, probably we would, but we can. So that's the example we're going to be looking at today, and we're going to go over how this works. Now, basically, we're using an SWA function, SWI6, which is OS byte. We're using subfunction 129, and this reads in a key from the hardware. Now, we specify 2 bytes in R1 and R2, and these make up a delay if the total value is less than 32767. So the top bit of R2's byte is a 0 basically, and then that will be a delay. So here we're delaying for 16, and we're reading in using SWI6, subfunction 129, the key read. And that will return the ASCII key press in R1, and we're moving that to R0, then showing it to the screen. So that's how we read in a single key. Now, if we want to do key tests, we need to use this function in a different way. It's still function 129 SWI6 we're using, but this time the top bit of R2 is set to 1, and this will define it as not waiting, it's just going to test a key. And what we need to do is we need to use the key code of the key we want to test, so 57 for up, 41 for down, 25 for left and 121 for right. We need to use that XORed so that all the bits are flipped. Now we're using this kind of hat symbol here, which will flip the bits. So we're doing 255 and then this correct symbol, and then 57 here, and that will flip the bits for this function. So we're testing key 57 here. We then use the SWI again, and the return will either be 255 if the key is pressed, or 0 if the key is not pressed. And what we're doing here is we're just showing the character to the screen accordingly, depending on those key presses, and that's all we need to do to test those keys. Now, of course, what you'll be thinking at this point is, how do I know what key is what? Well, what you want to do is you want to take a look at the key codes on my website here, and this is all of the keys, and it's these ones we're testing, but you could do the same for any other key on the keyboard. And because that function doesn't have a built-in delay, you can test as many keys as you want very quickly, and so you could do that quite nicely in a game with some controls for your up, down, left, right, fire, and whatever else your game requires. Okay. So that's how we can read in the keyboard on Risc OS. What about the Game Boy Advance? Well, the Game Boy Advance is super easy. Basically, we just need to read in from port 4000130, and we read in 2 bytes from that address, and that will give us all of our direction keys. If I just fire this up here. If I just fire this up here on the Game Boy Advance. Okay, you can see we're showing 3 double F to the screen here, and if I press up, down, left and right, you can see the keys are changing. The L and R triggers are being read in, and B and A, select and start, are all being read in, and that's all we really need to do, just read in from that one address, and that gives us all of our key presses. Nice and straightforward. Now the only other part of the code here is just a delay. We're waiting for VBlank just to slow things down for the screen. So that's all we need to do on the Game Boy Advance. Now the Nintendo DS is a little bit tricky. If we only want the basic Game Boy Advance keys, we actually read in from the exact same port in the exact same way. We get the exact same result, obviously I assume due to the compatibility with the classic Game Boy Advance. So that's nice and easy. We can just show that here. If I just fire up the Nintendo DS example here, and I press up, down, left and right, and the first 2 keys, enter, select and start, you can see they're all reading in fine. It's that second X and Y button, those ones that are a little bit tricky. The reason being, our code here is running from the ARM9, and the ARM9 can read in the Game Boy Advance keys. For a reason best known to itself, it can't read in the extra 2 keys. They can only be read in from the alternate ARM7 processor. So what I'm doing is I've allocated some memory here, Joy data. You can see I've also allocated pen data, which we'll discuss in a moment, and we're just reading in from that address, and it's the ARM7 processor that's doing the work of reading it in. How do we define some code for the ARM7 processor? Well, we need to specify it in the header here. I'm specifying the length here and the source of the ARM7 code. We're loading it into 380,000 here. That's the address in RAM that the ARM7 code is being executed from. And I've put the code itself in the footer here now. So we've got some code here for the pen driver and the joystick driver, and also for a future sound driver we'll look at later on, which also needs to be done from the ARM7. Now our joystick driver, the basic joystick reading routine is actually straightforward. Once we're on that processor, we just load in from 4000136, and that gives us the extra X and Y buttons. It also gives us a debug button, a pen down, and it also can detect if the lid's closed. There's a magnetic detector. So we can read in those. Now the debug, I believe, is something you're never going to see, and I think the pen may not work, the pen down may not work on the later versions of the Nintendo DS, so just be careful with that. But basically this is just reading it in, transferring it via the common memory area here that we've specified. You can see that's specified up here, and this will allow us, as you saw, to read in from the extra 2 buttons, and that will work just fine. Now the pen we have to read in a similar way from the ARM7, but it's much more complicated. Now you can see when I press pen down, you can see that bit changed there, and we're actually getting an X and a Y position here. You can see as I move across the screen, the X is going up, and you can see as I'm going down, the Y is going down. And that's the bottom right corner, and that's the top left corner pretty much. These are basically 12-bit values. So we're reading those in, and we're transferring those via 8 bytes called pen data in the common memory area again. Now, unfortunately, reading these in is not straightforward. Certainly not as straightforward as reading in from the joystick, but it's not too bad either. Now, I actually had to look at the source code of the ARM DevKit Pro development tools because I couldn't get this working from the documentation I could find. There were some particularities that were missing, but what I've done is I've managed to get it working, and I've actually tested this on real hardware, so as far as I know this is correct. So we're going to go over it now. Now we have to use something known as the SPI, and this has access to various pieces of hardware, but the one we're going to be looking at is going to be the pen. Now the X and Y axis are 2 separate things on this, so we're going to have to do these separately. We do the Y axis first and then the X axis, and we've got this function called getOnePen here, which will do each one. So we're going to be running this twice, and we need to select a different channel basically. So we're using channel 1 here, and then we're using channel 101 here for the X-axis. So we're running it twice with the 2 axes and storing the results in the pen data. Okay, now we're specifying 2 addresses that we need to use to work with the SPI. SPI control, which is for checking the status and setting the control settings, and SPI data, which is for reading back the result. Okay, now the first thing we're doing here is we are selecting that we want to read in from the touchscreen device here. So this is the sequence we need to specify for the touchscreen device, and we need to specify that we want the first byte. Now we read back 2 bytes for the 12-bit value, you see. So the C bit here is set to 1, and that will get the first byte when we run this. Now what we're going to do is we're going to send that to the data port, and then we want to select the channel using the data port. So we're sending that to the port in R3 here, and then we need to do a wait sequence. Now the wait sequence is basically that we have to test the bit here, the busy bit, and we just repeat until that is 0. Now first of all we do a wait, and then after that we'll need to transfer 0 to the data port and wait again as a strobe. So we've got a special command to do that just here. So first of all we're selecting the channel, and then we're waiting for it to be ready, and then we're reading in the first byte here. Now you can see here we're shifting to this to the left by 3 bits, and we're storing that in the top part. So that is the top 8 bits effectively, and then we're toggling to the second byte that we can read in. Now if you remember, the C bit here was 1, it's now 0, the other settings are the same, and this will get the second bit, and we're then using the SPI wait 0 to select that second byte here. We then read it in, and we're shifting it to the right by 4 bits because it's only 4 bits of this one that we want. It's a 12-bit value we're reading in. So all of this is a little bit complicated, but fortunately we can just use it in this way, and this is basically reading in the two 12-bit values. Now in this case we're storing them into a 32-bit address here, so we can then read them back just here. So we're using pen data here, but we've then basically got an X and Y value, and as I say, these are tested and seem to work just fine on my real Nintendo DS. Now this isn't using the calibration data, this is only a crude read, so it's a direct hardware read, but hopefully it's going to be enough to get you started, and as I say, proof of concept, it definitely works. So there we go. So that's all we're going to be covering today. We've had a look at the various systems here. We've learned how to read in from the joystick, keyboard and pen, just depending on what that system has. If you've liked what you've seen, please like and subscribe. As I always say, if you like the videos, YouTube recommends them to more people, which is a help. And if you subscribe, it encourages me to keep working on these systems, because you know, something like this, it took me a long time to get working, and as I say, I even had to go to source code of other people's work to try and figure out how to make it work, because the documentation wasn't clear enough, at least for me. Maybe you can figure it out, but I could not. Anyway, whatever you do, I hope you enjoyed this, and I hope you have some fun with the ARM and your Game Boy Advance DS or RIscOS programming. Thanks for watching today, and goodbye.